The SP4000 comes in two versions, black and copper. Same circuit inside, different material on the outside, and about $200 between them in price. Most people treat that gap as a finished choice. The look, the weight, the collector piece. That debate's been running since the SP3000 and never really got closed, mostly because neither side was coming at it from the engineering side. The chassis on this device is the master ground plane for the entire circuit. Once you know that, the whole question changes. Both versions run the same internal architecture. Astell&Kern built this around what they call OCTA circuit structure, which physically separates the power, digital, analog, and amplification blocks into 8 individually shielded sectors on the board. The PCB itself is any layer HDI, which allows microvias between any layer. And the reason that matters is that the shorter you can make the physical path between components, the less parasitic capacitance you're dealing with, and the less opportunity you give interference to bleed between stages that are supposed to be isolated from each other. The conversion engine is a true quad DAC, 4 AK4191 delta sigma modulators, each one paired directly with its own dedicated AK4499EX converter chip, 4 pairs, 8 chips total. And before any of that happens, the incoming signal gets buffered and reclocked by Astell&Kern's ESA system, running at 200 femtoseconds, which means you're correcting the clock before the signal reaches the modulator, rather than applying correction after the fact. The published numbers are identical for both versions. 131 decibels signal to noise at 1 kHz, 0.0003% THD plus N, and crosstalk sitting at negative 145 decibels. On paper, these are the same device. Both versions also include high driving mode, which engages parallel op-amp configurations to expand the voltage headroom up to a manufacturer-stated 8.2 volts RMS balanced. The claim is that the noise floor doesn't move when you switch it on. You're getting the headroom without paying for it in background noise. The output impedance on the balanced jack is 1.7 ohms, which for full-size dynamic headphones is completely irrelevant. But if you're running sensitive IEMS with an impedance curve that dips low, it's worth checking your specific earphone against that number, rather than assuming the match will be clean. Most high-end IEMS are going to be fine. Some won't. The chassis question. 904L stainless steel. What the Black Edition is machined from sits at around 1.35 million Siemens per meter in electrical conductivity. Pure copper comes in at 59.6 million. That's a 44-to-1 ratio, and it's not a small difference. Every circuit generates parasitic currents just by running. Switching transients, thermal noise, low-level contamination that varies too much to show up as a clean published number on a spec sheet. Those currents need somewhere to go, and the faster they drain through the ground reference, the less time they have to couple back into sensitive analog stages and cause problems. Any engineer who's spent serious time on a phono stage will tell you the same thing. Where the noise goes matters just as much as how much noise you started with. The copper chassis drains those currents faster, and in a circuit where the chassis is the ground plane, faster drainage is supposed to mean less residual contamination making it back into the signal, which translates, if the claim holds, into a quieter background, tighter transient edges, and a cleaner sense of space between sources. Astell&Kern's position is that you hear it in how fast transients arrive and how cleanly things resolve, not just in what the noise floor measures on a test bench. Both variants are running the same circuit on ground planes that are 44 times apart in conductivity. You listen and find out whether you can actually hear that. 3 tracks. Daft Punk. Giorgio by Moroder, 24-bit at 88.2 kHz. There's a synthetic sub-bass drop around the 1 minute 58 mark that puts real demand on current delivery and low-frequency transient control. And on the Black, it hits with immediate attack and stays dry through the decay. Clean control in the 30 Hz region that holds together the way a lower impedance ground path should. The copper takes longer to settle down there. The low end carries more physical weight, more body, and it doesn't resolve as fast. Not sloppy, just genuinely slower. and that character holds through the rest of the track, not just at the drop. Hilary Hahn playing the Bach violin concertos in DSD 128. The aggressive bowing on the E string generates harmonics that push well past 12 kHz, which is about as close to a real-world stress test for the quad DAC and ESA clocking as you're going to get. On the Black, those upper harmonics come through clean, extended and grain-free, without any congestion at the top. On the Copper, the fundamental body of the violin picks up warmth and density, and that warmth isn't an unwelcome thing in itself, but the outermost harmonic layer, the shimmer and air sitting just above the fundamental, loses some definition and goes soft. If that part of the frequency range is where your music lives, you're going to notice it. Miles Davis, So What, 24-bit at 192 kHz. The analog tape hiss embedded in this recording gives you something concrete to evaluate spatially, because it's a fixed reference point that either sits in its own layer or doesn't. On the Black, it sits behind Coltrane's saxophone rather than blending into it. There's real perceived distance between sources, and Paul Chambers's bass sits further back too, and you get a real feel for the physical space of the room, the reverb, the air, sitting in their own place. On the Copper, the overall texture gets denser, the stage compresses slightly, and the saxophone sits heavier and closer in the mix. Whether that's intimacy or congestion depends on what's already downstream. And it goes the same direction every time. The Copper warmer, denser, and spatially shallower, the Black faster, wider, and more open at the top. So, placebo? No. Astell&Kern documented the chassis as ground plane architecture in their technical materials. They didn't describe it as a sonic upgrade or market it as a warmer-sounding variant. The tonal shift follows from the engineering, from what a 44 times conductivity gap does to how the circuit manages parasitic noise. That's a different claim than saying copper sounds warm because it looks warm. Someone's going to bring up volume matching, because small-level differences between units can shift tonal perception in ways that get misread as character differences. Both were level-matched carefully before any listening. The differences held up, and they held up across material that's about as different as music gets. Because expectation bias doesn't produce the same directional shift in a Bach violin recording that it does in a Daft Punk sub-bass drop. The pattern was consistent all 3 times. The burn-in tells the same story. Out of the box, the Copper sounds closed in, heavy in the mid-bass, congested through the mids, and after 200 hours of use it opens up considerably. But the lower mid-range density never leaves. It's there at hour 1 and still there at hour 200, and that's not how a bias behaves. That's a material characteristic. The difference is real. The physics accounts for it. Which one belongs in your system? The Black's lower ground impedance gives you a wider stage, faster transients, and more extension at the top end. And it works particularly well with headphones that already run warm or tonally full, because the stainless steel chassis works against that character rather than adding to it. On the cable side, a gold-silver conductor brings a bit of lower mid-range body without pushing in the same direction the Copper chassis already pulls. And that combination makes sense. Running a warm cable into an already warm source generally doesn't. The Copper is more specific about where it works well. Small ensemble jazz, acoustic vocals, i.e. Ms that run bright or lean. Those are the situations where the added lower mid-range density actually does something useful, rather than tipping the balance too far. A pure silver OCC cable works the other direction. It opens the top end back up and tightens the transients in the areas where the Copper chassis softens them. The Copper fits fewer systems than the Black, but when the match is right, it does something the Black doesn't. And the ownership context matters here too. At 642 grams with a finish that responds to humidity and handling, the Copper does better when it stays in a case and lives in one spot. The Black, at 615 grams, with its PVD coating, handles daily use more forgivingly, though neither version is what you'd call pocketable. One thing worth keeping in mind is that the 1.7 ohm output impedance means the cable is part of the load interface, not just a signal carrier, so it's worth thinking about before you decide on a cable. Sonic Core Audio scores the SP4000 Black at 9.7 out of 10 and the Copper at 9.0. The gap between those scores isn't about a flaw in the Copper, it's about fit, and specifically about how many different systems that tonal character actually serves well. The $209 premium buys different metal, a different ground plane, and a different sound. And there's an audience for that trade. It's just a smaller one. At $4,290 for the Black and $4,499 for the Copper, what you're buying in either case is a transportable reference source, not a pocket device. Both versions weigh more than most mirrorless cameras, and that weight isn't arbitrary. The chassis is the ground plane, and the mass is part of what that engineering decision costs you. Buy the Black if you want the broader recommendation: precision, stage width, extension at the top, and a finish that doesn't require any thought. Buy the Copper if your chain already runs bright and you want the source working against that. Or if your listening is mostly small ensemble acoustic and vocals, or if you're going to keep this in a case and use it at a desk and treat it like the object it is. Either way, you're buying the same machine inside. The chassis is doing real electrical work.